Before we actually get into our notes for today, I want to do a quick little review of a concept we talked about last time that's going to play a big role in what we're going to do today. So here we have our quadrants, and I've got my angle that starts here. And remember, if I do one full rotation with my angle, what shape do we get? A circle. How many degrees do we have in our circle? 360 degrees, but in radian form we have false. 2 pi. 360 degrees is 2 pi radians. So, with our circle, our center of our circle is right here at the point 0, 0. And then our radius of this circle is always going to be a 1. So what we do is we call that circle a unit circle. It's called a unit circle because the radius is 1 unit. So unit circle goes together. So again, center at the origin, radius is equal to 1. So thinking back to the circle formula that we did deal with a little bit this year, you dealt with a lot in geometry. Which of those 4 choices under example 1 would be our equation of our circle with a center at the origin of 0, 0 and a radius of 1? False.
2.
4 would have a center at 1, 1.
Oh, 3.
It would be 3. That would be our equation of our circle.
Yeah.
And so what happens is that equation actually kind of mimics a theorem that we use a lot. A squared plus b squared equals c squared. It's just your c value is a 1, and 1 squared is 1. So we actually end up using Pythagorean theorem a lot when we're dealing with our unit circle. So now before we actually get to our picture of a unit circle, we're going to talk about some important triangles, some important angles that we have. First one is 45, 45, 90. Do you guys remember talking about this special triangle last year? It is a right triangle. 45, 45, 90.
I'm so sorry.
So when we are dealing with our unit circle, as I said, our radius is 1. So we're going to be using this 45 triangle in there. So our hypotenuse is also going to be 1. So if our hypotenuse is 1, we got to figure out what the lengths of those other 2 sides are going to be. So we're going to use our Pythagorean theorem for that.
I remember you said triangle.
So x squared plus x squared equals 1 squared. So let's solve for the value of x.
25.
So I have 2x squared. It's going to give us a 1. And then we do what with our 2? Divide by 2, so I get x squared equals 1/2. And then we take the square root. Well, what is the square root of 1?
4.
What's the square root of 2?
2.
Nah, I joked. It's the square root of 2. It's not a perfect square, so it stays at the square root of 2. But can I leave it like that?
No.
No. Can't have that radical on the bottom, so we got to rationalize. Multiply the top and the bottom by that radical. So 1 times radical 2 is radical 2. Radical 2 times radical 2 gives us a 2. So those other 2 sides of our triangle here are both going to be radical 2 over 2. Because it is. So our next triangle, the other special one you guys talked about last year, 30, 60, 90. So again, with the 30, 60, 90, our hypotenuse is still a 1. Because in a minute, we're going to be putting this in terms of our unit circle. So our hypotenuse is a 1. So now, think back to your equilateral triangles for a second. I'm going to try to make a connection here for you guys. equilateral triangles, what's true about an equilateral triangle? There's two things. Well, everything meaning 60, 60, 60 for the what? Angles, yes. And all the sides are the same.
There's 3 sides.
There are 3 sides. Good job.
I thought there were 4.
My daughter could tell you there's 3 sides, and she's 3. So, 60, 60, 60, or equilateral triangle, all the sides, or the angles are 60. So this one is going to be half of that. So since our hypotenuse is 1/2 of that for your 30, because it's half of your equilateral triangle, means that side's going to be 1/2.
I think it.
Because 30 is half of your normal equilateral triangle. Because normally it's 60, 30 is half. So take the side half of it, that one's going to be 1/2.
I got you.
So now we got to find the other side.
3/4.
No. Pythagorean theorem. So what's 1/2 squared? Please stop trying to guess. Or 1/4, yeah. Now what do we do with our 1/4? Subtract it. X squared equals 3/4. And now we do what? Take the square root.
Then we get 3 over the square root of 4 equals 3 over 2.
Radical 3 over 2. You can't take the square root of 3. It's not a perfect square. You can take the square root of 4. It would end up being a 2. So that other side's going to be radical 3 over 2. Oh. That was supposed to be down there in part B. All right, so now we're going to take this and we're going to apply this to our unit circle. So let's take a look at the back. So this diagram below represents the unit circle. So then based on our work from examples 2 and 3, no, I accidentally did B in part A. Right. So then based on your work from examples 2 and 3, we're going to find the ordered pairs that go in the unit circle. So again, here is the picture of our unit circle. As I told you before, what is the radius of a unit circle? The radius is 1. So all of these here are all going to be a length of 1. So all of those are 1. So now what happens is we put those triangles we were just talking about, we're going to put those inside the unit circle. So this first one here, this angle would be 30. There's your right angle. That one up there is your 60, but we don't really care too much about this one up here. We only really deal with the one that's in there by the origin. That's always the angle that we're dealing with, is that one right in there. What? The length of one of the sides is 1/2. Because it's half of the equilateral. So it's half the radius. Okay. So for our 30-degree angle, the side opposite in the triangle we were just dealing with was 1/2. The other side of our triangle we found to be radical 3 over 2. So what ends up happening is on the unit circle, when you draw that 30-degree angle in there, it hits the unit circle at a specific point. So the coordinates of that point end up being, since this side of the triangle is radical 3 over 2, that's like your x. So you're moving over radical 3 over 2, that's like your distance for your x. from the triangle that we did on the first page. Mm-hmm. And then it goes up 1/2. So on the unit circle, the coordinates for a 30-degree angle would be radical 3/2, comma 1/2.
Oh, it's kind of like the regular graph.
Yes. It's a different graph, yes, because it's got the unit circle on there. So then our next one, our 45-degree angle, again, it makes a triangle if you connect it down to your x-axis. So what were the two sides of our 45? Look on the page before. What were the two sides of our 45?
Radical 2/2.
Both of them were radical 2/2. So down here was radical 2/2. Going up there would be radical 2/2. No, because you can't divide the 2's. The second one on the bottom is now under a radical. So our coordinates for the 45-degree angle would be radical 2/2, comma radical 2/2. Because for your triangle, you would move over radical 2/2 and you'd go up radical 2/2 to get you to that point. And then the other one, our 60-degree angle. That's the last triangle we have there in the first quadrant.
That's just reversed the 1/2.
It would just be your 30 reversed, yes, because your triangle is just in a different order now. So it would be 1/2 radical 3/2. So then what ends up happening is those points end up getting repeated in the various quadrants. So if you think back to last class, with my 150-degree angle here, what was my reference angle that went with 150? 30. So 150 is going to have the same coordinates as your 30 with one exception. Does anybody think they might know what that exception would be? Yes, because 150 is in quadrant 2, your x value should be what? Negative. So since your reference angle is 30, the coordinates are the same with the exception your x would be negative. So for 150, our coordinates would be negative radical 3/2, comma 1/2. What about what? The hypotenuse is still 1, it's a radius. This side here is your hypotenuse. That's still a 1. This, no,
That angle is a 35, right?
30 degrees. So then this 135, which one is that going to mimic?
Why is it a negative all the time?
Because you're going to the second quadrant, your x is negative there.
Oh, I see it now. How come 1/2 is
Because you still went up a positive 1/2.
You see the graph? Okay, so it's like a y and an x-axis.
So 135 is like which one? The 45. Your reference angle here would be 45 degrees. Again, your x would be negative. So it's negative radical 2/2, comma radical 2/2. Because you're moving to the left along your x-axis, so your x is negative, and then you're moving up.
And then the other one is 1/2, comma. Sorry, no. No, it's negative radical 3, or it's radical 3/2, comma negative 1/2. Or something.
Switch it around. Negative 1/2. X is still 1/2. You just change it to be negative. And then it's radical 3/2 is your y. You're still going up radical 3/2. So then going down into quadrant 3, our x's and our y's are both going to be negative because you move to the left along your x-axis and we're going to be moving down. So for 210, what would our reference angle be? Well, it wouldn't be negative, it would just be 30. Reference angles are always positive, so our reference angle there would be 30. It's 30 degrees from that x-axis. So that means it's the same values as your 30. You just make them both negative because you're in quadrant 3. So it's negative radical 3 over 2 comma negative 1/2. .225 would use which one? What's our reference angle for 225?
2 radical 2, so negative radical 2 over 2 comma negative radical 2 over 2.
Negative radical 2 over 2 comma negative radical 2 over 2, because your reference angle was 45. So it uses the same values as the 45. It's just because you're in the third quadrant, your x and your y's are negative. And then the 240, you'd have a reference angle of 60. So it's negative 1/2 negative radical 3 over 2. Be negative. The y's are going to be our negative. So 330, what would be our reference angle for that one? 30. So that means it's going to be the same coordinates as 30, but only your y is going to be negative. So it's radical 3 over 2 comma negative 1/2. So the 315 would have which one as its reference angle? The 45. So this is radical 2 over 2 comma negative radical 2 over 2. And then our last one there, the 300, that would have a reference angle of 60. So that's going to end up being 1/2 comma negative radical 3 over 2.
If you were going to draw the finished triangle, does it matter which side it goes
It always has to go to the x-axis. So like for my 300 here, if I wanted to complete my triangle, I would go up to meet my x-axis. That's always the home position, if you will. Now there are just a couple more values we missed. For 0, that would be 1 comma 0, because you'd move out to the right to the end of the circle, which is 1 unit, and then you wouldn't go up or down any. How about for 90? 0 comma 1, because you wouldn't move left or right at all, but you would go up the 1 unit. 180, negative 1, 0, and then 270, 0, negative 1. So in example 5, for each of the following angles drawn in standard position, give the coordinate pair from the unit circle. So we're going to figure out where on the unit circle it falls, and then we're going to write its coordinates. 0, 1. So negative 120. Negative 120 would come down this way. There's negative 90, so 1 more. There's my negative 120. It would fall where the 240 is. So that means its coordinates would be negative 1/2 and negative radical 3 over 2. It would have the same coordinates as your 240. So B495, first thing I'm going to do is subtract 360. So really I want to look at 135. So what are the coordinates for 135? Look at your unit circle. There you go. So then the coordinates for 495 would be the same thing, negative radical 2 over 2, comma radical 2 over 2. Because since it was larger than 360, it's going to go around one whole full time. And then I had to figure out where it was going to end. Pi over 3, I want to convert that to degrees. So 180 divided by 3 gives us 60. So we just got to figure out what are the coordinates of our 60. It'd be 1/2, comma, radical 3 over 2. You just look at your 60 up above. Yeah.
What if we don't have this?
Oh, you should always draw it. That's the way it's going to help you remember it.
This is a really big drawing.
Yes, but the values all repeat. Well, 3 times, I'm turning it into degrees first. So what is our degree? 270. So yes, it would be 0, -1.